So by now you should really know the basic structure of the urinary system and the gross structure of the kidney. Every day your blood passes through your kidneys about 400 times. The blood enters the kidney via the renal artery, the waste is filtered out and leaves the kidney via the ureter, and the clean blood then leaves the kidney via the renal vein. But what is actually happening inside the kidney for that to happen? Well, you've got to delve deep right down inside the kidney, right down to a microscopic level to find out. If you do that, what you would see are lots and lots of tiny tubules called nephrons. In fact, there are about 1 million of them in each kidney. If you could unravel them, they would stretch for about 60 kilometers. And these nephron tubules are supplied by a network of capillaries. So as the blood has entered the kidney in the renal artery, it splits out into smaller branches and smaller branches and smaller branches until it reaches the very outer part of the kidney, the cortex. And the arteries now are so small they're called arterioles, and in fact they're called the afferent arterioles, and these are the ones that supply the nephrons with the blood. So the blood enters down this afferent arteriole, and it's at really high pressure. We say it's got a very high hydrostatic pressure, and that arteriole then forms this ball of capillaries called the glomerulus, and that is at the start of the nephron. It is surrounded by a cup called the Bowman's capsule, which is the beginning of the nephron tubule. And because the blood is under such high pressure, lots of stuff starts getting forced out of the blood at this point and is collected in that Bowman's capsule. All of the small parts of the blood are included. So most of the fluid, all the products of digestion that are dissolved in the plasma, like glucose, amino acids, so water, fats, ions, and the urea get forced out. All that's really left in the blood at this point are the blood cells, red blood cells, white blood cells, and large proteins that are too big to fit through the capillary and out. That blood then continues off out of what we call the efferent arteriole and carries on its way, and we'll talk about where it goes next. Now this process is called ultrafiltration. Now the problem with this is there's lots and lots of good stuff that's just been filtered out of the blood, and if that fluid called the filtrate that's now come out of the blood carries on down that nephron and out, it will be excreted as waste. Now you do not want to get rid of the glucose, you do not want to get rid of the amino acids. There's lots of good stuff in there that we need to keep in the body. So the next part of the nephron, and pretty much the whole length of this wiggly tube, is dedicated to taking back the good bits back into the blood. So it's a bit of a clunky system really. What we're doing is getting rid of too much and then taking back the bits we want, so that all we're left with at the end of this tube are the waste products. So the fluid starts to move along the tube and it comes to the first wavy part of the nephron, which is called the proximal convoluted tubule. Now 85% of selective reabsorption, as it's called, happens here. All of the glucose gets reabsorbed here. A lot of the amino acids do, and a lot of the ions do here as well. Now that blood, that efferent arteriole that left the glomerulus is now carries on its journey and actually wiggles around the nephron so that the molecules can pass back into the blood where they're needed. Most of this happens by diffusion. The glomerular filtrate continues on its way then through the proximal convoluted tubule and then down into what we call the loop of Henle. Now the loop of Henle really is used to reabsorb water. This is where water is reabsorbed. You can see that it stretches down into the medulla part of the kidney where there is a high concentration of salts which causes more water to move out by osmosis and enter the blood. So that's good because we don't want to excrete too much water. The fluid then continues on its way. There's not much left in it now, there's some water left in it, some salt, some urea, but pretty much all the good molecules that we want have been reabsorbed by this point. The distal convoluted tubule is used for fine tuning and slight adjustments to reabsorption and what we need. And finally, the glomerular filtrate, as it's called, passes down the collecting duct where other nephrons will join in into one major collecting duct to eventually end up draining into the ureter, and that will be the waste. So by this point, at the bottom of the collecting duct, you really only want there to be urea, some water and some salts, and that is what makes up the urine.